You know, when you think about it, most of the problems we face with energy security and pollution stem from our attempts to heat water in a way that both maximizes profits and remains marginally safe enough for government agencies to approve them. Most of the ways that we create electricity involves the conceptually simple but technically dangerous task of boiling water to create steam to drive a turbine that spins a dynamo in a generator. Electric power stations are basically giant tea kettles that either use the heat coming from the fission reaction of deadly radioactive materials to boil water, or ancient lumps of carbonized wood that release their own radiation as well as arsenic and a surfeit of CO2 into the atmosphere when burned, or ancient toxic liquid hydrocarbon goop, usually from politically unstable regions, or gases released using chemical processes that poison our water supply. But does heating water need to be so problematic? And do we need it to create electricity? Obviously no. We have technology to turn dynamos directly using wind and cold water from streams and rivers and waves and tides, and the combustion of biofuels and internal combustion engines and geothermal heat. We have materials that turn light photons directly into electrons and electric current. So of course we can create electricity without heating any water at all. And if we want to heat water, we can create hot water without using any fossil fuels or radioactive rocks at all. Do we need electricity to heat water? Obviously no. We can heat water with efficient on-demand heaters that burn biofuels directly, or we can combust biofuels in combustion engines coupled to CHP, combined heat and power heat exchangers, and actually get both electricity and hot water from the same process simply by capturing the waste heat that engines give off. Technically, these are all simple and are being done all over the world at various scales. But of course, politics and profit get in the way, and any move away from coal, oil, gas, and nuclear power, especially when talking about large-scale processes that are controlled by large-scale capital investors with huge political clout, it's a problem. We normal citizens don't have a lot to say in that domain unless we can prove there's a better way. And the problem I see is that most of the people we call consumers don't know enough about the alternatives to make strong demands or strong consumer choices. So forgetting about industry for a moment, what can we do as citizens to get out of hot water when it comes to hot water? What can we do at home to prove to ourselves that there's a better way and to live it every day? To answer that question for myself, I turned to the poorest section of one of the trouble spots in the world to see how people who have no power, political or technical, get along. I chose to live in a community where the electric power and the water were always being cut, where I would have to figure out how to get hot water without getting into hot water, politically, financially. Studying hot water provision in the slums of Cairo, I became interested in the issues of hot water demand and provision in and around Old Cairo in the spring of 2006, when my thesis advisor, Randall Crane, and some 25 graduate students from our urban planning program at UCLA came to visit on a field research trip, and we took them to the historic Cairo slum community of Darb al-Ahmar and the informal garbage recycling community of the Zabalin, or garbage pickers, in Manshiat Nasser. Having recently built and installed our own solar hot water system on the roof of an unfurnished apartment that my ex-wife and I had rented in the desert development of Beverly Hills, Egypt, I became curious how the urban poor were dealing with their own hot water needs. In our case, living in a new model community with limited funding, we were concerned that the layout of our apartment immediately determined the choices we were to make as consumers. Each of the 3 bathrooms and the kitchen were plumbed and wired with the expectation that the renter would install a separate electric water heating appliance into each room. The pipes to each room were separate circuits, meaning that a heater installed in the kitchen could not provide hot water to any of the bathrooms or vice versa. To have hot water in each room would have meant purchasing 4 separate heaters. Now, at an average price of 500 Egyptian pounds for each small 50-liter heater, we would have spent 2,000 Egyptian pounds, which is just 500 Egyptian pounds less than the average materials cost for the kind of 2-panel, 200-liter solar hot water heater manufactured by the Wadi Foods Company, whose educational initiative, the Wadi Environmental Science Center, I was helping design. My now ex-wife and I chose instead to convince the landlords of our apartment to allow us to install the solar hot water system on the empty roof and run temporary pipes 4 stories down the air shafts to the bathrooms. It wasn't an easy job, but the learning experience was worth it. It forced consideration of how the built environment biases and constrains consumer choice. The question then became, what constraints are there on consumer durable choices in the 2 communities we visited on our UCLA research trip? In both areas, after presentations by community representatives talking about development initiatives, I asked whether any work was being done on overcoming barriers to alternative energy solutions and other clean development and inflation-resistant environmental technologies. My question was prompted by a paragraph in a 2002 paper in the European Journal of Political Economy that stated, quote, "The question becomes urgent why not everybody is employing best practice technologies, even though these technologies are known and yield, by standard means of calculation, a positive net present value. In, for example, the field of environmental economics, much attention has been paid to the seemingly paradoxical evidence that firms do not employ those environmentally friendly technologies that, according to standard calculations, yield positive net present values. This paradox is often referred to as the energy efficiency paradox and has given rise to an extensive literature trying to resolve it. See, for example, Howarth and Anderson of 1993, Jaffe and Stavins 1994, and Sutherland 1991. The question that began to gnaw at me was, what is a best practice technology for the diverse problem sets that we find in a planet of slums, to quote Mike Davis? Who determines what constitutes an advantage in areas where all costs are high, from materials costs to information costs, relative to the average income of the population? How do the urban poor perceive the trade-offs they must make and the opportunity costs they face when considering how to, or even whether to, heat their water? And if solar domestic hot water could be proven to be economically superior to all other options, what might be impeding its widespread use? How do we investigate barriers to implementation? And how might we use our findings to change policy? For example, government support for businesses and energy efficiency, such as low custom rates on efficient devices, equity loans, tax incentives, etc. You can see CHEDID 2000 for that. And how do we do it so that we can help everyone employ best practice strategies? Dr. Salah Al-Hagar, AUC's engineering professor, whose nameplate is still on the defunct rooftop solar energy lab there, was quoted in an English-speaking Egyptian newspaper as saying that urban Cairo had implementation problems for domestic solar hot water, in large part because of its density and the sheer dimensions of its